In this section, we want to learn about applications of systems of linear equations in two variables. In the first problem, Susan can choose plan A or plan B for her long-distance charges. For each plan, cost in dollars depends on minute used per month. That's represented by the graph. In the sentence, what it says is cost in dollars, meaning the output depends on the input, which is minute per month. So minute is represented by the value in the x-axis, and the resulting cost is represented by y values. In the first problem, if Susan make 200 minutes of long distance calls for the month, which plan costs more? Susan make 200 minutes, so input value must be 200 minutes. I drew a vertical line. And the question is, which plan costs more? So y value is higher, the cost is higher. Obviously, this red line costs more, so plan B costs more. Second question is, how much more does it cost than the other plan? Now we have to compare the price. We have to know the actual value. So I drew the horizontal line, and then I found that this red line, plan B, is 18, and plan A, this blue line, which has lower value, has $16. The difference is $2. For what number of long distance minutes do the two plans cost the same? They must cost the same, so they have to have the same y value, and that happens at the intersection point. So I drew the horizontal line here, and that is $24. And I drew this vertical line, and then that indicates the minute. That is $300. That's the question. If the time spent on long distance calls is less than this amount, which plan costs more? What we have to do is we have to observe what happens in this region because it's less than that amount. In that region, the plan B costs more. When we draw the vertical line, red line is always higher than this blue line. So plan B costs more. In this problem, the sum of two numbers is 33. One number is 2 times as large as the other. What are the numbers? There are two numbers. I will represent it as x plus y. When we add them up, that becomes 33. And one number is 2 times as large as the other. So x can be represented as 2 times y. So what we have to do is we have to solve the equation. X can be represented by 2y, so we will write 2y instead of x in the first equation. Then we have 2y plus y equals 33. So 2y plus y is 3y, which is 33. We divide by 3 on both sides, then y equals 11. So we have one number that is 11, and that is y, and we have to get x. X is twice more than y value, so that's 22. Keiko will rent a car for the weekend. She can choose one of 2 plans. The first plan has an initial fee of $45 and costs an additional 50 cents per mile driven. So first plan can be represented by a linear equation with the initial value $45. So I wrote the first plan as y equals 45 plus 0.50x. X represents mile, and output value is the cost. The second plan has no initial fee but costs 70 cents per mile driven. So that's just 0.70 times x mile. In the first problem, the question is for what amount of driving do the 2 plans cost the same? Costs are the same, so y values are the same, so we can write an equation 45 plus 0.50x equals 0.70x. So we subtract 0.50x on both sides. So that is 45 equals 0.20x. So we divide by 0.20 on both sides, then x equals 45 over 0.20. You use your calculator, then that's 225 miles. What is the cost when the 2 plans cost the same? We can use either equation because the output values will be the same. So that'll be cost at 220 miles. That equals the second one looks simpler, so I will choose it. It doesn't matter. Even if you choose the first one, you will get the same value. When you use your calculator, you will get 157.50 cents. In the following problem, there are 2 families, Russell's family and Lee's family. The Russell family's water output rate for the sprinkler was 35 liter per hour. So we can write the water use at 35 times x hour, and Lee's family use water 30 liter per hour. Here, there is one variable hidden. We can indeed write equals y because the water use depend on the hour. But in solving the equation, well, you don't necessarily write the equation with two variables. In this problem, what they're saying is the combined total hour is 65 hours. So both families combined total hour is 65 hours. And the total output of the water use is 2,125 liter. So what happens here is combined total is 65 hours. So if the Russell family's hour of water use is X, then combined total is 65 hours. The remaining hour out of 65 hours will be Lee's family's water use hour. So it'll become 65 minus X. They're saying that the combined water use is 2,125 liter. So when we write 35x plus 30 times 65 minus x, that equals 2,125. Because this one, this time becomes 65 minus x. So we have 35x plus 30 times 65 minus 30x equals 2,125. So that is 5x plus 1,950 equals 2,125. Therefore, we have 5x equals 175. When we divide by 5 on both sides, we have x equals 35. So the x is 35. That's Russell family's hours of water use. And then the other family's water use is 65 minus 30. That is 30 hours.